Hi Tiana, so thanks so much for this question. I've just adapted the actual photo that you sent me into these 5 equations. So for background, it was about you can buy like these 4 different food items and it's got different total prices. The first thing you want to do when you're like trying to convert words into maths is condense it down. So for the linear equations here, we've actually got 5, which is a bit unusual. We don't actually need 5 because we've only got 4 different unknowns that I could see. And so in order to solve it, we actually don't need all 5 equations. So I might just go ahead and get rid of this 4th one because it's got a lot of information. We definitely want these 2 because they've got zeros. And yeah, maybe not this one's. So we're going to take these 4 equations, 1, 2, 3, and 4, and we're going to try and use Gaussian elimination to solve them. I think the very first step is, rather than having all these words in here, I want to create a system of linear equations and then label them with actual values. So what that might look like, let's say ham is H, let's make chicken C, let's make sausages S, and maybe let's go K for steak, so they're all just unique. So I'm going to put for all of the equations, I want the H's in a row. So the first one is 3H plus 1K plus 1C plus 0S equals 12. Then for equation 2, we've got actually 0H, we've got 2K, we've got 2C plus 3S equals 16.5. Equation 3, 3H, 1K, 1C, 3S is also 16.5. And then we're skipping 4. Equation 4 is 2 ham, it's a little bit out of order, but 2 ham, 2 steak, 3 chicken, 1 sausage, and that's 20. So what we can do with this now is, if we just take the coefficients, we can create a system of linear equations in Gaussian elimination form. And I will write that out now. Okay, so as an augmented matrix, this is then what I get. And we can start to try and incorporate some Gaussian elimination techniques here. So what I'm looking at is I want to subtract one row from another. And the easiest thing I can do first up is to go, I guess, do our next matrix, is I want to subtract row 1 away from row 3, because that will cancel these 3 and just leave a 3 there. So let me write how that would look. Cool, and this is what our new augmented matrix will look like. I think it's actually easiest here. I was just weighing up whether we keep eliminating or whether we take pause and actually solve for one of the variables. So what we found is that essentially 3 sausages equals $4.5. That means that 1 sausage is $1.5. Sorry, 1.5. And it would be worth, in my eyes, subbing this back into the equations, because then we can maybe even simplify it further. So what we'd get in terms of this is the first equation didn't have any anyway, so it's still just 3H plus K plus C equals 12. The second one becomes 2K plus 2C plus 3S, which we know is 4.5, and that equals 16.5. So if we take 4.5 from both sides here, we're left with 12. And even simpler, we can take out a factor of 2 here from the left-hand side and then divide both sides by 2, which even gives us just k plus c equals 6. So that's pretty good there. Our third equation is solved, so we use that to find just s equals 1.5. And then our bottom equation is going to be 2h plus 2k plus 2c, plus 3c, plus our 1.5 equals 20. We can simplify that to be equals 18.5. Okay, and now at this point, I think it's kind of nice. Once we've simplified everything down, we can then come back to our augmented matrix, and it should be easy to solve. And you could pause here and actually just do it by substitution, sorry. But since you specified, okay, I want to know how to use Gaussian elimination, we'll bring it back into the augmented matrix. And so that will be now just a 3 by 3. So 3, 1, 1, 12. And I should mention, by the way, that how I've kind of done it and eliminated one of the equations and taken it out and put it back in, that's not the only way to do it, but that's what makes the most sense for me, in terms of just following, like, okay, like I think it's very easy to get overwhelmed with Gaussian elimination when you see, like, oh, I've got 5 different equations, like what do I prioritize, cancelling out, etc. But I think when you kind of reduce it as much as possible, it just makes it easier to work with. And so what I can see here is that these ones are going to match, and so my operation for the next matrix is going to be row 1 minus row 2. Alright, and then when I do that, I can see that I've got 3 hamburgers equals $6. So each hamburger is $2. And again here, so we've solved 2 out of the 4, right? Again here, it's probably good to take pause and see what kind of effect that has in our other 2 equations. So on equation 2, that's not going to do anything. It's still just k plus c equals 6. But equation 3, it has an impact. So here in equation 3, we've got now 2 times 2 plus 2k plus 3c equals 18.5. So that's instead 2k plus 3c, sorry. We've got 18.5 minus 4, which will give us 14.5. And so now we've got 2 equations, 2 unknowns. I'm still going to solve this through Gaussian elimination, just because I want to show that it can be done, can basically be used the entire time. So I'm going to put that in just a smaller augmented matrix, and then we can finish it off. Okay, and we only need to do 1 more elimination here, and then we're pretty much done. So what I'm going to choose is actually, I want to first multiply row 1 by 2. So what that'll give us is 2 to 12. And I'm actually just going to write that in. So 2 to 12. Then with that, now we can, subtract row 1 from row 2, and it'll cancel out nicely. So this is going to be row 2 minus 2 row 1, and that will give us a final matrix of row 1 stays the same. And then row 2 becomes 0, 1, and then 2.5. What that tells us is that one of our chicken burgers equals $2.5. Therefore, if we come back to our other expression, we know that k plus 2.5 has to equal 6. So k, a steak burger, will be $3.5. And so overall then, for all of our items of food, we can say that a steak burger is $3.5. We can say that a chicken burger was $2.5, we can say that our hamburger was $2. And then finally our sausage was the very first one, and that was $1.5. Cool, so I hope that's helpful. That's how I would use Gaussian elimination to solve this problem. It's an annoying concept, like it just takes a long time to do the questions, but that's how I'd approach it. I hope that makes a bit of sense for you and helps you out a bit. Yeah, thanks so much for submitting a question. Feel free to send in more to us. I really like this one. And yeah, if you found it helpful, enjoyed, we'd love it if you could like the video, subscribe even, support us on our socials so we can continue to do this. So thanks very much. Yeah, hope that helps.